Alright, this might be a shorter video, but we'll see how it goes. So anyway, the Iron Gostling guy has sort of paid attention to the argument for a change. It's actually on the right subject. And describing it wrong, but so what? It's close enough.
If we drop...
And so he's recognizing that the paradox of this free energy thing exists no matter what theory you choose, because it's something built into gravity. And, they're really just not paying enough attention to the fact that gravity is a time-dependent force, that you're actually collecting energy as you're in gravity, free-falling. If you're connected to something, then you will lose your energy to whatever you're connected to. So you can make lots of these different arguments, and the question is, well, why can't you take advantage of this? And it's ambiguous. Let's just say nobody's making those arguments, so you can't just say this is why in a simple way. One of us can't say it because nobody analyzes any of this stuff anywhere on the available information highway. The available highway doesn't have these conversations on it, so it's really hard to discuss stuff that isn't discussed by anyone. That's really not very good. What camera is that now? No, that's the right camera there. I don't know, the camera's got messed up. The wrong camera's doing the wrong thing now, but whatever. Alright, so the simple dilemma, again, is that you could drop something in increments, okay? And, his mistake is he's saying that every time you drop it and you go to collect it, you have to collect it by dropping it the same amount of distance. So he has in his drawing a bunch of springs, and he's saying, look, the spring stretches twice the amount, and no, springs can move just a tiny amount, and it's not a problem. So this, if you collected this energy, something falling from this height to this height, in these little increments, then it would add up, okay, to more energy than it takes to go back to this spot, twice as much in this case. And you could make it 7,000 times as much. So we're sort of back to the bullet and the gun analogy, or the lever, where you can increase the free energy exponentially. But anyway, so let's just deal with this case. Obviously 2 units of compression, so if you said each unit, let's just say it was 10 pounds, okay, and 10 pounds, and 10 pounds, and 10 pounds, you could figure out that that's 40 pounds total, and if you put 40 pounds of pressure on the same object, it would raise it up there somewhere, way up there. And so you have more than enough energy to re-lift the same object. The catch is you can't collect it in this manner, okay? This won't do you any good. So if I compress a spring with 10 pounds, and then I drop 10 pounds, 10, what would it add up to 10 pounds? 5 pounds from 4 times the distance or whatever. So I'm going to hit it with 10 pounds. Won't do me any good, because the spring can't see that as more energy. It's already compressed at 10. You need to compress it at 11, okay, to make it move. And then 12 to make it move here, and 13 to make it here, and 14 to make it here. So hitting it repeatedly with 10 won't do you any good. But if I took 2 springs, so for each one of these steps, if it was a different spring I compressed, well, then I can put 10 pounds in each one. Alright, and so in parallel it works, in series it won't work. So that's one argument. Now the catch is that I could take something that weighed 5 pounds, so I can compress the spring with something that weighed 10 pounds, and I could put something that weighs 5 pounds on top of it, and I'll get it to go twice the velocity. Okay, and twice the velocity means 4 times the distance in gravity, right? So I get the same scenario, where I can, use the compression of just 10 pounds and end up with a 5-pound object 4 times the distance. well, it doesn't have all of that energy. The argument can be made, and you can't collect it. And so even if you, like I said, if you had a 15% loss rate, obviously 15 and 15 and 15 and 15 would end up being 60%. So you end up losing 60% of the energy, which is more than half, which explains another reason why you might not be able to collect it. So regardless, the point is that this in the comments on his video, they're relating it, at least rationally, to the lever argument, and they're still talking about things that couldn't possibly matter. Like somehow this is a rotational momentum is somehow different than regular momentum, and it's exactly the same. You just count the distance and how fast did it cover that distance. So a circumference, everybody knows a circumference is just a straight line. You can just say it's this long a line, right? This circle equals this length of line, and it's related to pi and the diameter, so you can calculate and know it's that length of line. So if something moves, yes, if something moves straight, okay, it's less distance. And if it curves, well, then that's a longer line. Okay, you can see that this is longer. All right, which means that it has a little more velocity and therefore momentum. But it's clearly just the length of the line. It doesn't change anything. It's just a length of distance. So even on the lever, it's still just a length of difference, and the velocity would have that velocity. Now, obviously, the longer the lever, the rotational part becomes almost invisible because the line becomes straighter and straighter, especially if you confine your movement to this side. Movement up here, yeah, it really matters. The distance changes a lot. Here, the distance doesn't change much. So you're not changing its velocity much from a straight line. Here, there's a big difference between the straight line and this line, okay? Here, there's not much difference. So you're not changing the velocity very much, okay? It's such a small amount that it really doesn't matter. And then the other argument is about the rotation of objects as they're rolling. And in the Brozo experiment, the idea is that the rotation doesn't necessarily match the ground. You could think of the thing rotating, and on a sticky surface, this rotation has to exactly match the distance you're traveling. But on a slick surface, this rotation could be much slower. Like you only get one full rotation for a very long distance. So you can rotate something where it's just hitting a little bit of friction, it's rotating a tiny bit, and there's a tiny bit of extra momentum in the rotation. All right, very small amount of energy stored in the rotation of the individual little atoms that are moving a little bit faster in this direction, okay? Because all the atoms are moving this way, and then some of the atoms are moving this extra bit, and that's all you're really saying. And so, but it's again a small amount. The rotational momentum is a small percentage of the total momentum in the direction, because the rotation isn't perfectly tied to the surface because it's a low friction surface, so it has a little bit of spin. So you can obviously, on slick surfaces, you can put backspin on objects and actually have them rotate opposite to the direction they're moving. Alright, but it could steal a small percentage of the total energy of the object. So anyway, these are the things they're dealing with, and they don't have answers for them, and which is proving the point that they didn't really think about this stuff very well from the very beginning, and they haven't really paid any attention to the actual arguments that have been made for 2 years. And so we'll see how they deal with the fact that, until they recognize that this is about pressure, it's about weight. Okay, and 18 pounds doesn't obviously just convert to 9 pounds or to 36 pounds, but it's the function of a spring. Springs allow you to give back energy at any speed. So I could put in, right, a speed, a momentum, a weight, Okay, and the weight's going to be defined by how fast the object's moving, right? 4 pounds at twice the speed can be 9 pounds, right? And 9 pounds at half the speed could be 4 pounds. So that's the trick, and the spring collects it. All right, so it would collect the weight of the falling object, okay, which would be 1/2 the weight here, and 1/2 the weight here, and 1/2 the weight here, of the total weight that shot it up, which would be, let's just say 18, well, let's just say 20, since I'm using tens. So 20 gets you up here, and then you get 10 tens. But the 10 tens really don't have the capacity to produce the velocity of 20. The 20 velocity can't be made. You can't go backwards. So the point is that if I put a 20-pound object on top of the 10-pound compressed spring, I'm not going to get the same velocity out. I'm going to get half the velocity. So if the 10-pound is on there, then I'll get back the same velocity that produced the 10 pounds of weight. Put the 20-pound of weight on there, I'm not going to get the same velocity. I'm going to get half the velocity because I got twice the weight. So springs can give it back at any velocity. So whatever you're moving. So again, I compress a spring with 10 pounds. I put 5 pounds on it, it goes twice as fast. I put 1.25 pounds on it, it goes 4 times as fast. So I change the velocity because that's what springs allow you to do within a range, the range of the spring constant. All right. And levers are, as I've been pointing out from the very beginning, levers do exactly the same thing. You convert, okay, the small v over here to a large V over here and commensurately change the size of the weights, all right, and have a proportionality. So you can put a big slow thing in and get a small fast thing out, and vice versa, and you clearly don't lose any energy. It conserves the momentum perfectly. Now Brozo says he's got a decisive experiment that proves that you don't conserve momentum. So anyway, this hopefully will lead to them acknowledging that it isn't a rule of physics, a law of physics, that you have to conserve momentum. Feynman would say it, Lewin would say it, all the physicists would say it. It's not a trivial thing to say, oh yeah, we don't have to conserve momentum. That's stupid. Yeah. And to me, the real thing to understand is the whole vector scalar thing. Maybe they can get to that and figure out that why are they calling one a scalar and why are they calling the other one a vector? Is there any reasoning to that? And they'll realize, no, there isn't any reasoning. They chose it for mathematical reasons. Not because there's any physical difference between the kinetic energy of a train going down a track and its momentum. Both of them, if you believed in both of them, you'd have to concede they're both vectors. They're both in one direction. Okay, yeah, so you can't do this plus and minus crap. You can't sit there and say, because I pushed something this way, I undid pushing something that way. No, they're both real momentums, and they both have to be included in the real universe. And if you're doing an experiment where you're making free momentum, you're probably doing something wrong. All right. So I think that's... Don't need to really play. His video isn't terribly coherent. So he's realizing it's a 3 to 4 deficit. Okay, but he's only saying 3 to 4 because of the way he's drawn the experiment. Okay, he's just drawn it poorly. So instead of doing the simple drawing I did, well, whatever, I won't redo my drawing. He's done it this way, and so he's basically having the spring's compression add up to the same thing as the distance you drop an object from to create that compression. And those two things aren't proportional, obviously. You can gain velocity from something. You can drop something and have it. I could drop something from this height and have it hit the scale and only move the scale a tiny bit. So I don't have to move the scale as much as I drop the object. And if he does it based on spring compression, which also makes it easier to understand, the relationship is 2 to 4. Okay, that's the problem. And they just shouldn't exist. That difference, there shouldn't be any way to make free energy this simply. Just launch things quickly and collect their energy slowly as they fall, and you get 4 times the energy for twice the energy to lift it, and that can't be right. It can't be right in the sense that there's got to be a reason why we can't collect it. We can't take advantage of it. And I would argue part of the reason is that 4 9-pound impacts aren't quite the same as one 18-pound impact. Okay. I think that's probably just enough to paraphrase where we are. So the peanut gallery, okay, has responded with absolutely nothing. I mean, I could just read this comment. It's just so silly. First of all, you have to change everything into SI units. He didn't have them in any other kind of units, so that doesn't matter. Secondly, there is a Wikipedia page named spring constant. That doesn't have anything to do with it either. So he's acknowledging the spring constant. He's pointing out that we already know that springs move twice the distance, blah, blah, blah. So that's irrelevant. Well, it redirects to Hooke's law, but that's the same. Hooke's law is not going to explain why 4 9-pound impacts doesn't equal 1 18-pound impact. It's not going to explain why. All right. Always try to find something on Wikipedia or YouTube first. So really silly in the sense that everybody's already done the looking. We've looked for any experiment that would, isolate this basic function of what compresses springs, what do springs store as energy, anything that would give any insight on that subject, and obviously in 2 years nobody's found anything. Use the YouTube search bar often. So again, this is just such tripe. Try in Hooke's law. How is, again, Hooke's law is not going to solve this gravity paradox. This is a gravity paradox. And then he says, tongue-in-cheek, but K equals mg divided by x. Again, useless information. All right. Then MC says, let's see if you can see. Yeah, you can see this stuff well enough. I see you calculated the work one at a time. But that was the whole point, is to just point out that you could collect the energy in 4 units, and the total of those 4 units of dropping energy doesn't equal the energy it took to launch it. Okay. It seems the displacements have to be calculated from the real position of the spring. No, the whole point is the spring could be displaced. Just a stiff spring could collect the energy in a tiny amount of space. So it doesn't have anything to do with the dropping distance. The dropping distance is much, much bigger than the distance the spring compresses. So that's just a flaw in his drawing. And like I said, if he drew it right, it would look even worse. It would look like the video I did yesterday where I pointed out you can just lift the 2 mass, just 2 units of distance, and you have the same weight as the spring and the same exact spring compression. You actually have the 20 pounds. I lift 2 10-pound objects 1 unit of distance each. Okay, so I've only gone 2 units of distance with 10 pounds of weight, and then I can launch a single 10 pounds 4 units of distance. That's the problem. That's the paradox. Okay. I would define the rest point of the spring as where it stops when no weight is added. Yes, again, the rest point and the compression point of the spring just depends on the spring you use. So you can use a spring that collects the energy with very little movement in space, or one that requires a stiff spring versus a loose spring. But you make an interesting argument, because if the rest point of the spring is defined as where you start attaching weight, then the person who attaches the first weight will say the displacement 2, while the second person, Why is he adding a second person? We'll say the displacement is 1. I mean, so he's trying to turn it into a relativity argument. Oh, it's just so funny. As a result, they calculate different work, so I don't know why he's bothering with that nonsense. It's just hilarious. Way off the subject, MC. Alright, Brozo just goes on, you know, it's just how he feels and blah, blah, blah. Let's see, I'm sure it makes no difference, but I may have to think by redrawing it that way. So he's having a problem with the fact of stretching springs versus compressing springs, and it really doesn't matter. There's no way to draw it differently. You just have to draw it, and that's what you haven't done. So you're saying I have to draw it differently. You've never drawn it. If you draw a lever, you can't make any sense out of your theory. Okay? It doesn't make any sense. The lever oscillates perfectly, but somehow it can't launch at the same speed it oscillates. It's just too silly a proposition. Alright, anyway. So he says, just take care of yourself, blah, 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 blah. Alright, so here's the John Walker again. But Steve, I can see that the kinetic energy is the same for each mass plus its rod. So we don't even know what its rod is. He seems rod obsessed. But nobody can say anything about the momenta. It's all in the drawing, but nobody can say anything about it because there's only angular momentum here. So there's no angular momentum at all in this experiment. It's just dropping things straight down. So that makes absolutely no sense. It's all due to Goofy with her nonsense speeding lever experiment. Yeah, that's right. It is all due to my pointing out that this circumstance exists. This is how springs work. You can compress them slowly, okay, with a weight over a time, and you can release it with a higher amount of pressure over a shorter amount of time. So you can change the time it takes to accelerate something. See, time and acceleration are connected to each other. Alright, so I can accelerate something to a higher speed if I apply the force over a smaller amount of time. Brother. The total force of the spring. Alright, thank you. I mean, you could say it has 9 pounds of pressure on it, but you could also say, if you just change the time factor, that's at 9.8 meters per second, it's 9 pounds. But if I change the factor at which I'm going to be releasing that pressure, I could argue it's 8 pounds if we change the weight standard instead of a 10 pound to a 5 pound. Alright, anyway. I'm still working, let's see, I'm still thinking momentum applies to objects themselves. Alright. Thank you for pointing out the following, John. No, so there's nothing in his statement. I bow to your superior knowledge on these matters. I mean, that's just hilarious. The guy's a lunatic. I don't know why. So, Stephen Bro, you think he has superior knowledge. He is actually a free energy nut. He thinks chili peppers are magnetic. But I would ask you to consider the following reason I'm still thinking momentum applies to objects themselves. I'm probably wrong, but here's how I have been thinking about it so far. So he has all this doubt and confusion about how it functions, and he makes these arrogant, obnoxious videos saying, I have proven. I mean, that doesn't make any sense. He's supposed to be publishing right now a video that decisively proves that levers don't work, that they don't conserve momentum. Yeah, what sense does this make? Yeah, no, it doesn't make any sense. Although I recognize that the lever is rotating about its axis. So here they are talking about levers when the experiment being shown has no lever in it, has no angular momentum in it, doesn't have any of those things at all. And they just couldn't be further from the subject of the actual video. The actual video is about this. It's about springs and weights dropping in this straight line. That's it. There's no angular momentum anywhere. It's just so fucking stupid. So anyway, then this John Walker guy says, I'm a humble man, just so funny. I make mistakes all the time. Then why are you so arrogant? I guess you've never learned from any of them. You don't learn that, you maybe ought to think about it before you open your mouth and type a bunch of ragged shit. You ought to make sure you're right. I mean, fortunately, I'm right most of the time, so I don't have to worry as much as you. Anyway, my specialty lies elsewhere, like he's a specialist in something. Hilarious. But I like to rehearse these high school problems. So like this is brought up in a high school somewhere. So where did they bring up this paradox in a high school somewhere? So why don't you show me any indication that any high school teacher has ever noticed this defect in the reasoning? Just go ahead, show us anyone drawing it and showing how, hey, you know what, I could take two 10-pound weights and lift them 1 unit of distance, and I can shoot a 10-pound weight 4 units of distance with that energy. Because your distance crap is just that. See, so what we've got here, basically, ing is stuck now because he's cracked. Okay, the earthquake happened, it's cracked open, the fissure in his little brain, and he's going to be stuck having to acknowledge the simple truth that this is about time. Time is really important. So the thing he mocked and laughed at as having anything to do with it, he's going to have to realize that, yeah, it does have something to do with it. Okay. You are right that your masses go further in the straight line. My bad. So I don't even know what he's talking about the fact that they go further. Again, in rotational momentum, it's just about how much distance you travel. An arc is a distance. That's your velocity. Your velocity isn't your component in this direction and your component in that direction. That's not your actual traveling velocity. Okay. So I try to find the correct equation, but like everyone, I try to debunk the trolls. So he calls the people who raise the issue trolls. So the subject he's trying to figure out the answer to, he calls that trolling. Okay, but it is more or less your task to do some of the measurements. Don't underestimate the importance of that. So again, this is one we all agree on, the outcomes of this one. So you're just sitting there with this paradox, okay, of the fact that those numbers don't add up. Okay, only numbers or equations don't convince no trolls. So there's nobody, again, he drew the picture, okay? Pictures are really good. And he's saying when he draws the picture, it doesn't work out. So I'm merely trying to predict the outcome of your experiments. Well, again, and your prediction is that you don't have to conserve momentum, which obviously, in my opinion, is a retarded, on its face, stupid, moronic prediction. Okay. As a team, so to speak, have to go. Yeah, whatever that rubbish could even mean. Okay, so then Brozo just goes on about how he has to go pay his electric bill. So, anyway. So this is progress. I'm just saying it's progress that, this arrogant shit has conceded, oh, there is an argument here, isn't there? Yes. I can't just sit there and say my theory works, right? Because this theory doesn't work. Okay, it doesn't add up. We should have free energy machines. Okay, he's sort of conceding. That's what it explicitly says. And I'm saying, well, yes, it even says it louder with a pressurized vessel. You can see it. I drew that yesterday. And the lever really shows it too. But springs do it too. It's right. Okay. So, I think that's enough. Alright, so we'll see if there's any comments and then be on my way. Just interesting. We'll see where it goes. See if the crack, if they don't figure out some way to put some crazy glue in it and fuck up their progress. So at least they've made the progress of acknowledging there's a subject. Okay. Yeah. So we'll see. No chatters, no viewers. I mean, that's, well, it says 10 here. And it says none here. So I wonder which one is lying to me. Yeah, which one is a lie? 10 or 0? 2 people liked it, so I guess there has to be more than 0. Yeah. Anyway, it is funny. Alright, so it's obviously being lowly viewed. I mean, it seems like there was 1 viewer, and then there's no viewers, and then there was 1 viewer, and then there was no viewer. Right? You can see that little charty thing, right? Yeah, you can almost see it. So it's not telling me much. Now there's only 7 in here, and there's 1 in here. I don't know. It's pretty damn bad is what it is. So obviously, takes a while for whoever's subscribed to this crap. It takes a while for them to get the notice. But anyway, it's okay. It's a decent enough video. I made my point. Blah, 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 blah. What are people getting in believing in kinetic energy? That's the big thing, right? It's because Newton, Descartes, and Galileo did perfectly fine, okay, with MV. They were actually getting really close to describing all the interactions that could be described. I mean, they were figuring out that heat is a form of energy, and that's part of the leakage in experiments. You could just watch the heat and calculate it as, oh yeah, that's the stuff we lost. You know, that was part of the energy is that heat loss, that waste energy, it could be called. You know, they were getting all of this stuff. I mean, the other guy, you know, they killed him in the French Revolution, but because he was the head of the tax. You know, well, anyway, he did these brilliant experiments, you know, where he put things in glass and then, you know, basically evaporated them back into their original materials, and did some very precise, for that time, experiments, you know, isolating the fact that it's energy in, energy out, you know, that it's conservation of momentum. But Descartes had already basically made that point pretty clearly, that, you know, what the world looked like to him was the energies put in, you know, by God, and it just keeps swirling. It doesn't go away. It just you just follow it. It just keeps going somewhere. Things hit each other, and it moves, and it goes to there, and you just follow it. That simple. Yeah. Yeah, and all that worked. And why change it? Why fuck it up with this dramatically weird notion that, you know, you can bang, you know, heavy things into light things and make free energy, and every time you bang a light thing into a heavy thing, you lose megatons of energy? Why bother with that? Alright, modern physics. Are modern physics used for anything practical, or is it all mush and fables? Well, that's the catch, is right. I mean, you can go. NASA will talk about kinetic energy when it comes to talking about the yield it gets from its rocket fuel, and it'll tell you the fuel has 6,787 joules of energy per gallon or something, but it never tests it. And the problem is it's not consistent, because as they move the rocket, as the rocket gains velocity, the fuel gains more joules of energy. And they accept that paradox. They accept that silly notion that if I'm going 50 miles an hour, I have 7 million joules of fuel. If I'm going 10 miles an hour, you know, I have 8 million joules of fuel. You know, that their fuel is getting more powerful, you know, as their velocity increases. I mean, obviously silly. You know, but yeah, all these numbers are just used for relative comparisons in a lot of respects. So it doesn't matter whether you have it in the right units, because you're just making a comparison between 4 units and 8 units. So if your units are way off, who's gonna tattle on you? You know, nobody. All right. It seems like people are getting desperate, just wanting free energy to exist. Well, obviously that's some of these people, like the John Walker's. He's a free energy nut. Okay, he thinks he's going to do some Tesla thing or something. You know, he's going to perfect one of Tesla's inventions or something and make the free energy. You know, there's no kind, but you can't blame that on the Gostling guy or I don't think Brozo believes in any of that. He's just accepting that the Bible says, okay, and the minister says, and the Pope says, and the bishops say. So he's just being an obedient disciple of standard jargon from the standard assholes. Now, I'm sure he could see through that crap, when it comes to evaluating a politician or some other thing. I don't think he bows to the king, but who knows? Maybe he is a king bower. He assumes the king must have special knowledge and special blah, blah, blah because he's a king. Maybe that's how he functions. He's just an obedient servant to the Borg. But anyway, by providing bad, inaccurate experiments, yes. Well, that's the, it wouldn't matter what Brozo's agenda is. He would always defend it badly. So he's not the kind of guy you want on your side in a fight. Because, yeah, he's going to end up, blowing up his own soldiers eventually. Okay. It's surprising people don't want to double check science from 300 years ago. It's surprising that they don't require any evidence, right? I mean, they just say this stuff. I mean, I could go back. I don't know when the first. I'd certainly heard of quarks, but then they made that Daryl Hannah movie, with the Steve Martin and Daryl Hannah in the Cyrano de Bergerac thing, the big nose guy, remake, and she was a physicist, and so she was talking about quarks and strange quarks and up quarks and down, and and it was just like, why do people believe this? I mean, it was that bad. Like, okay, yeah, this really is Daryl Hannah physics, right? This isn't real physics. It's just too damn silly. But everybody believes it. Yeah, Roxanne, that was it. Yeah, not a bad movie. I'm just saying, if you like comedies. But yeah, come on. All of that crap, why would you even, you should be suspect that the physicists are calling things strange. I mean, why don't they just call it the queer quark? I mean, come on, it's just too fucking stupid. I mean, it smells like bullshit, okay? In every way, it has the appearance. And, until they show me it's singing and dancing, I'm not going to believe it. But everybody else does. The whole Higgs boson story. Oh, you need the magical Higgs boson because that creates mass somehow. You're like, what the fuck? What are you talking about? How could that make any sense? Yeah, but whatever. I'm just saying the standard model is just such mushy crap. Again, like I said, you can't draw it. They show you the little symbol of it, the nuclear, symbol with the little electrons and and that's not exactly the truth. Okay, that's not the truth. But that's not what their standard model looks like. I mean, so what's the point? I mean, it's full of the woo. Oh, the electrons really don't have a position. They're really not anywhere, So photons interact with the I'm not anywhere electron. I mean, the whole thing is just so bad. You're just saying, yeah, why do people believe without seeing any evidence? Why? So, I mean, Brozo has convinced himself that somehow it's true that it takes 4 times more gas to go twice as fast. Why would he believe that without, thinking about it and saying, well, wouldn't somebody have noticed by now? I mean, wouldn't they notice that by going 60 miles an hour, they're using twice as much gas? Ooh. I mean, that's a pretty steep penalty. And then there's all the obvious stuff. Again, you make your bowling ball a little bit lighter and you throw it a little bit faster and you will gain more kinetic energy. So why wouldn't bowlers do it? Come on. I just don't know why these arguments aren't at all. I mean, they don't even dent their confidence. They just sit there and arrogantly keep saying, I believe, it's the truth, it's the truth. And they really don't have anything. Again, the very fact that you can't find a single experiment in the annals of physics demonstrating kinetic energy doing any work. I mean, any experiment that shows you, this increase that you get. All right. That levers produce free energy, frankly. I find that Ian's experiment with him pushing on the spring to shoot an object up seems very comical. There's nothing, no, that's perfectly legitimate. I mean, he didn't do the experiment. I mean, he's just drawing something on a piece of paper. But there's nothing wrong with what he drew except for the fact that he has these giant stretchy springs instead of, compressed stiff springs. He seemed, I don't know what that is, fat glued, just trying to show the experiment. Fatigued. I think he's fatigued because he's trying to figure out why the theory, kinetic energy theory, doesn't work. And it doesn't work because their understanding of gravity doesn't work. The units of distance are not units of energy. They're just not. Time. Gravity is about time. You can't gain the energy from it unless you're in it. And again, the energy you're gaining is, in a sense, the second the difference between 9 pounds and 18 pounds is a real difference. It's not just 9 pounds of difference, because a regular spring will tell you it's not the same thing. 2 9 pounds don't equal 18 pounds. You have to split those. You have to do it in parallel, not series. I mean, the fact that there's these rules about how it works. Like electronics, there's rules. And energy is about the time in which a force applied over time. And the shorter the time a force is applied over, the more pounds of pressure it applies to something. The shorter the time you release the energy in a spring, right? The faster you allow the spring to release, the higher its velocity. I don't know how to say it some other way. The point is that levers and springs and hydraulics all take advantage of the fact that you can collect energy at one rate and you can release it at another rate. And that's the advantage of those objects, those mechanisms. And so it's not about changing the total energy stored. It's about changing the rate at which you release the energy. I mean, I've said it from the beginning, right? The 5-ton train and the 10-ton train, it's the same thing. You're just changing the rate at which you would release the energy, right? So you could compress a spring with a 10-ton train going 5 miles an hour, and you could release the energy with a 5-ton train going 10 miles an hour. It makes perfect sense in linear motion. Again, gravity is always going to be a problem because you're really not getting... It's not about distance, it's about time. All right. So at least now we have 2 viewers. These numbers are way off. The other thing says 13. It is funny. It's great that they have all these analytics. It's just too bad they're not accurate. Yeah. Look, you have all these nice charts, but it doesn't mean much. I guess it only works when you start having a higher volume or something, maybe. Maybe it's just that the view rate is so low that it's uncalculable. Some kind of crap like that. 6 likes, so there had to be 6 different people, right? So I guess that's some indication that the 13 number is probably closer to the truth. Alright, 2-minute warning and such. So say something or else. How can there be 2 viewers and also 13 people watching? Yes, I'm just saying it's obviously YouTube doesn't have this perfected. Yeah, whatever this is, they haven't perfected it. It's like it's in its a brozosian state. It's not fully functional. Doesn't get right answers. Too dumb to be unhappy. Huh, that's a very interesting screen name. But, yeah, you could just call yourself Mr. Glib. Yeah. Anyway, smoke addict. Yeah, that's right. For 50 years. Yeah. So, what's the big deal? How does that exactly affect you? Anyway, somebody should make a GoFundMe to have an experiment to have hydraulics and levers. Well, I mean, you shouldn't need a GoFundMe. That's just saying, let's do it the inefficient way. So I'm sorry, but I just don't know why you people think these are good ideas, these websites that just, steal some more of the money. I feel like having hydraulics would make it expensive. The hydraulics could be as simple as a syringe. So, if you get it, see, I have some syringes, but they're pretty poor quality. They really stick, in the beginning, and then it gets much easier to move the further out you go. Well, this one, it sticks in all kinds of places. So you need a very good one, okay. But technically, that's all you need. 2 syringes tied together on one side, 1 syringe on the other side that move relatively freely. And it'll demonstrate the very fact that you could plow the 10-ton train into one side and you have no choice but to produce the 5-ton train going twice the speed on the other side. And vice versa. And by the vice versa, I mean you'd have to explain where half the energy was lost when you did the 1 syringe and the 2 syringes barely move, half the movement. And you have to explain, how did I lose half the energy? But anyway, the point is it works like a lever, like a spring. The hydraulic system will show you how momentum works. You don't have to crank it up to thousands of pounds or any of that shit. I mean, you could theoretically do it with a glass of water or some other kind of, you could do it with displacement in water. You could do it lots of different ways. I'm just saying, whatever way you do it, you have to do it, minimally precisely. Oh, I thought when say hydraulics, I thought you mean in things like heavy machinery. Yeah, no, it's the same mechanism. You just do it on a smaller, lighter scale. So, Mindless Marbles made a new video. Oh dear, that ought to be just horrible. A new view. Anyway, that ought to just be terrible. Let's see if we can find it. I suppose it'd be worth seeing what kind of crap it is. So is it on the archive channel? I guess it is. We'll look there first. No, that's just the Brozo one there. So it must be on his regular channel? I don't know. I thought he put the experiments on one channel and something on the other. So what's this one? Draft Science is laughably wrong about levers. Yeah, I just don't know how I could be laughably wrong. But anyway, complete something or other. So I don't know. So this is just silly, right? Quote my videos, and his counter argument will be, stick figures or something.
Here is an example where draft science.
Let's just read it. We won't bother with his computer voice. So this coward, okay, does all this shit talking about other people, using their real name, different things, and, he has to hide. Here's an example where draft science takes a video out of context. So I didn't take anything out of context, so that's just a lie. And then displays a double standard. It didn't happen either. In response to a couple of experiments I showed, experiments, and I explained how, it's a real thing. Anyway, Draft Science references a video by another YouTuber, Stephen Bro, saying it contradicts mainstream physics and conclusively validates him. Yeah, that's what it did. That's why I referenced it. The Brozo's own admission is, it didn't come out the way it was supposed to. It was supposed to be 1.4 and it wasn't 1.4. So he's conceding the argument, for fuck's sake. However, he leaves critical parts of the video out. There's no critical parts I left out, so it's just another lie, okay? His video's a piece of steaming shit, okay? Nobody with a brain would even play his videos because it's like playing, diarrhea on your channel. No one's going to tune in to watch that. And as a result, he distorts the conclusion to make it falsely seem like it supports him. Now, it clearly supports me in the sense that the 2 mass was obviously going very, very close to twice the speed. I mean, half the speed of the half mass, twice as far out on the lever. It was exactly as I drew. The outcome visually couldn't almost be more perfectly consistent with what I've argued. So this is just such a lie to try to say that somehow that experiment didn't look exactly like the ones I drew. It looked exactly like what I drew. Alright, so we'll skip over the computer reading the crap. Is that a different sound? Oh, he has 2 paragraphs of crap. Consider a lever with a 2-mass object at 1 radial distance, and a lever with... See, he can't draw anything. He can't do it. He couldn't just draw this on a board and explain. So now he has to, in text sentences, describe a physical circumstance. It's just such a fucking bullshit thing. So you have to do this word problem. Consider a lever with 6 people on the left side of the train and 4 people on the right side. And there's 4 lights across the top, and there's, 3 banana peels in the hallway. Alright, consider a lever with a 2-mass object and a 1-mass radial distance, and a lever with a 1-mass object at 2 radial distance. So he's saying a 2-mass on one side, 1 distance, and a 1-mass, 2 distances. Exactly what I've been drawing for 2 years. Okay. And suppose we push on the lever from one side using a compressed spring. Since the same energy is delivered to both setups. Oh, he's doing both on the same lever at the same time. I didn't say anything about that. That wasn't in the video I showed. It's not part of the argument because Brozo concedes that part. That part's irrelevant. I didn't show any of that in my video clips. So you're just a liar. Gary uses the wrong notion of E equals mv to conclude that the 1 mass should be launched with twice the velocity. It is in the fucking experiment. So, I mean, this is how desperate they are. An experiment that Brozo admits pretty much does show that. I mean, so anyway, in support of his claim, he references a video by Stephen Bro. Yes, okay, that's what I do. There's not a 3rd paragraph, is there? No. So now he's just going to play clips of me.
So we'll do Brozo first. It's pretty conclusive evidence, okay? So 2 mass, you put a 2 mass here, and it goes 1/2 the speed. So you do the experiment, same compression of the spring.
Right. So this is exactly what takes place in Brozo's experiment. Exactly what I showed, okay? The 2 mass will go 1/2 the velocity of the 1 mass out here. It's obvious in the video. You can't miss it. The 1 mass is going insanely fast compared to the 2 mass.
So you compress the spring, the same amount for both experiments. You compress it to, say, this distance. You move the lever here. And you put a 2 mass here, and you get a speed. And you put a 1 mass out here, and you get a speed. And this is obviously twice the velocity. Okay, but this goes. All right, you got numbers 19 and 11, pretty close to 2 to 1.
Yeah, and it's by Brozo, shitty filming, shitty frame rates, all of that kind of crap. So I'm just saying, obviously, if you look at the fucking experiment, it's clear the goddamn thing is moving very, 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 very fast.
So this is Brozo's experiment, one you got to duplicate or prove broken. Okay, because it basically proved the point that the same force, okay, produces two different amounts of energy. And in this case, twice as much energy over here. Okay, so I just put the mass further out, I get twice as much energy out of the same spring compression. Doesn't make any sense. Isn't conservation of momentum, because I would compress the spring by dropping the masses, and obviously I would drop this one from 4 times the height, I would drop this one 1 unit of height, and I would compress the spring the same amount because it's a weight. All right, so we haven't fixed any of this. Just save that name for posterity. So
there's absolutely nothing wrong with that clip. It accurately describes the experiment, accurately describes my argument that the lever proves your theory unviable because it becomes a free energy device. Okay, the fact is you can, with the same force, make the bullet with 2,000 joules, or you can make the gun recoil with 2 joules. That doesn't make any sense. The spring doesn't have 4 joules or 4,000. No, it can't do both of those.
Great effort you make, Steve. The better these videos get. So the video absolutely proves free energy by the kinetic energy formula. He shows an experiment that just overtly proves it. And he said
it does. Even if you use their statistics, even if you use their reduced numbers, it's still 1.7. Okay, it was supposed to be 1.4. So you still have 0.3 of free energy. I mean, you can't evade that. So I mean, you know, you want to argue the numbers? Fine, go ahead and argue them. But I don't think you can make any kind of reasonable argument that the experiment doesn't show free energy. The lighter object goes substantially faster than 1.4.
Hey, great job. And then he's wondering, he's calling somebody else thick and clueless? Like, fuck. All right, more accurate, better mechanisms, honing it down on the truth. The more he will decry them. Well, I'm not decrying this one. I'm sitting there showing it, saying, look, just prove me right. What's the argument? Where's the argument here?
Yeah, I'm just saying, it's decisive. Thank you, Stephen, for doing the video and proving me right. Okay, so what's this text on here? Look how confident he is about this video. You can't get a more visually obvious experiment. I mean, it's visually obvious. It's going twice as fast. It's visually obvious.
Pass out here, okay, twice the distance, and he gets pretty close to 2 to 1 results, right? 19 and 11. So this one takes 19 ticks to hit the same spot, the other one takes 11 ticks to hit the same spot. 2 to 1, pretty much decisive. So there's a little spring over here, there's the same distance moved. I mean, it pretty much proves the point. There's nowhere anything close to kinetic energy being rational. The same spring compression creates 2 completely different energies. One of them has 80%, whatever the right number you want to use, right? It's not twice the energy, it's 1.9 more energy. Okay, so how do you explain that? What's your brilliant explanation, fuckheads? I mean, you keep making this argument that this doesn't happen, and yet it's shown right in front.
I don't understand. I can't, you know, this Mindless Marvel's character, I just can't understand him because, yeah, these videos prove me, yeah, what I'm saying is perfectly correct. So, I don't know why he's playing these clips of me saying things perfectly reasonable.
In the Brozo video, when he did do the experiment to see how much energy, okay, how much velocity the lever produces, it produced the 2 to 1 relationship. The 2-mass billiard ball moved with half the velocity.
Right. Okay, so we've heard all that. Yes. Let's see what he writes now. So this is his counter argument. All right, Gary insists that the results hasn't been explained by his critics. The problem is the ratio of velocity isn't anywhere near the claim they are, what he claims they are. Well, I'm just saying within Brozo's error, margin of error, clearly 11 could be 10 and 19 could be 20. Clearly that's in the range of Brozosian error as a description. And I would say just looking at it visually, you would never conclude down or you would go up on those numbers because it's clear, looking at it visually, that it's damn close to 2 to 1. In Gary's prediction, the ratio of velocity should be 2 to 1. You can see it in the video. I'm just saying, go watch the silly Brozosian video. You'll see the yellow object go twice the distance. I mean, it's just obvious in the same time. Okay. In the mainstream physics prediction, with the idealization that the lever has negligible mass compared to the pool balls. The mass of the lever isn't an issue because Brozo used a full-length lever. He wasn't using a catapult. Now, if he uses a catapult, yes, they'll break the results, but it's still, the fact is, it didn't come out anywhere near 1.4. Okay, the ratio of velocity should be 1.4 to 1. Now, what results did Stephen Bro actually get? Let's see.
The ratio of...
Oh, sorry, we don't need the computer to read that. Let's see. I guess it's here. Okay.
would say that the yellow being half mass and twice the longer lever should go.
So this is where he combined 4 poorly done versions of the experiment. I'm just saying when you saw him do it the best, it was damn close to the 2-to-1 relationship. But whatever. You want to do this one little, you want to play a little game here and say it doesn't matter what it visually looks like, go ahead and play the game. The point is it visually look like 2-to-1.
Twice the speed, but in fact, let's see what they actually did go. So I say I divide 19.75 divided by 11.65 equals.
So those are the numbers he's using, 11.65 and 19 point something or other. So, and so he comes up with a number 1 point, you could argue you round that to 1.7. Pretty far from 1.4, clearly.
Yeah, so 1.698. It goes 1.7, so 1.7.
So that's an impossible number. So you could argue that Stephen Bro is so incompetent that he can't get the right numbers. But I'm just saying, if you watch the physical experiment, it will not be your conclusion that the yellow one's only going 0.7 times faster. It's clearly going more than that.
The other ball actually went 1.7 times the speed.
So we see that the ratio is actually 1.7 to 1, which is precisely between the two predictions.
Oh, so what are you going to say? So will you please then tell us all why Stephen Bro keeps getting answers right in the middle of the two predictions? Why does that keep happening? Because he did that in his other fucking experiment. But this one was obviously, I'm just saying, go watch the experiment. You'll have no doubt the yellow ball's going twice as fast. All right.
How is this conclusive for Gary's prediction?
So he didn't make this video about Stephen Bro's other video where he got a number right in between the two results and he claimed victory. Stephen Bro claimed it confirmed his theory. My prediction was 12, he got 14, Stephen Bro's prediction was 16. So somehow Stephen can post a video claiming victory in that circumstance.
The ratio is literally half.
I mean, you're the hypocrite here. Quite obviously the hypocrite. And what you're not saying is, well, shouldn't we all doubt Stephen's experiments? Stephen sucks at doing experiments because here he's gotten a result that isn't either theory. If you watch the video, okay, go watch the video. There's no doubt.
Way between the two different predictions.
Well, we don't need this thing to read it. Okay, the ratio is literally halfway between the two different predictions. Okay, let's see what else he's typing here. Now, here is something else. Stephen Bro himself actually addresses why the ratio is 1.7 does not match 1.4, although his specific argument that one end of the lever needs to be cut halfway. Yeah, that would be retarded. For the 2 mass is not true. Yeah, so he's literally suggesting a fix that would break the experiment entirely. He rightfully points out that the lever can take up non-negligible mass from the entire setup, whatever that even means. This means that you should expect an exact 1.4 ratio outcome. So again, there's no expectation by somebody rational. Somebody rational knows levers actually work. They don't dysfunction insanely. Nobody'd use a lever if they couldn't gain leverage. That is, actually create this differential in velocity to mass ratios in terms of pressure. If you can't create more pressure, why would you use the lever? All right. I mean, it's kind of an obvious statement. All right, despite being the same place on the lever, my example goes 1.69 faster. Excess lever mass probably accounts for not being closer to 1.4. So that doesn't make any sense. The two experiments were done on exactly the same lever, and it was a balanced lever, that is the same amount of lever on both sides. So that's an idiotic suggestion of a flaw. Because ideally, half the lever could be cut off while launch. So he's actually reciting Stephen Bro's moronic statement that it would make sense to take the, here's the fulcrum in the middle, lever on both sides. Because his experiment now said that basically says the lever will not influence the experiment. Okay, because you have the same amount of mass of the lever in the experiment, and he wants to cut it off, okay, and the extra half for only the 2 mass. So the 2 mass would be a broken lever, and the 1 mass would be with the full lever, and he thinks that makes sense. obviously that doesn't make any sense at all. Alright, so we can skip this. That's just wrong. Alright, why did Gary leave this out? Okay, so my example goes 1.69 faster, excess lever mass. Well, I'm saying I watched the video, okay, it was clear to me that, you know, where Brozo decided to have a half frame and where he finished and his frame counting, I could say that's his problem, okay, in terms of how he sets up the experiment. But the fact is that I can take the 19 and 11 and I could, within perfectly reasonable boundaries, say that's within the margin of error. Okay, and I can just say 20 and 10 and say that is the actual experiment. But whatever, it doesn't matter. The point is Stephen Bro admits this experiment didn't work. Okay, it's not 1.4. He didn't get the right answer. He got way too much energy. So see, I mean, you're just not dealing with that real argument. So let's see what he says here.
Move the lever here. And you put a 2 mass here.
So it's the same clip
again. 1 mass.
Okay, you don't really need to see the same clip again. Let's see what he says. His prediction is that you should see a 1 mass at 2x distance get launched at twice the velocity. The point is I'm saying it's impossible theoretically for it to do anything else. There's no theoretical possibility, and I showed the lever perfectly oscillating in those circumstances with twice the velocity on one side as on the other side. And I made the simple argument that all I have to do is stop the lever at some point. I put a nail in and make the lever stop. Those objects have to retain the velocity they have. They can't get rid of their velocity. They have it. And the fact is, on one side, I'll have half the velocity with a 2 mass leaving the stick. And on the other side, I'm going to have a half mass going twice the velocity. And that's just a fact. Anyway, distance to get launched at twice the velocity as the mass in the other case, which means the lever should have exactly the same angular velocity. So the angular velocity is so irrelevant in levers that are a meter long. It really just doesn't mean anything in both cases. Here is Ian Gostling showing that this does not happen. So Ian Gostling is now in quite some doubt about, I think, the integrity of his experiments, but whatever. So this is the unbalanced lever, okay? This is the catapult. So this is the catapult experiment. It's not a lever experiment. Notice there's no lever on the other side to balance the weight of the lever. So the lever is now got to be lifted by both springs. And the fact is that's going to change the center of mass of the lever. So the center of mass of the lever would have been just changed by the mass you put on it if he had kept the rest of the lever on the lever, the balance. I mean, this is technically a lever, but it's not a balance. Okay. I mean, look, we don't have perfect vocabulary, but you can understand there should be a word for the difference between a lever, a stick, okay, in the middle, with the fulcrum in the middle, and a stick with the fulcrum not in the middle. Those things are different, and they shouldn't be called the same thing. That's ridiculously stupid. So yeah, we already played all this crap. So obviously, the flaw in that experiment I've already gone over, so I shouldn't have to go over it again and again. We're not even sure if he has the weights right.
So
Gary makes a completely wrong assertion about Stephen Bro's results, so that's just not accurate. The assertion that Stephen Bro's results were certainly nowhere near consistent with kinetic energy theory is a fact. Okay. Falsely saying they support him when they clearly don't. No, they clearly do. What they don't do is clearly support kinetic energy. Anyway, he completely ignored the fact that the lever could take up a non-negligible amount of mass. I don't even understand what the fuck you're talking about. Sorry, no sale. The lever is a balance. If you have the same amount of it on both sides of the fulcrum, it's kind of irrelevant, which Stephen Bro pointed out in the very video Gary references. And again, you've already stated that Stephen Bro's solution is to cut the lever off, which is stupid, as you've already conceded. And both Stephen Bro and Ian Gosling's video contradict Gary. No, they don't. Does Gary still want to say Stephen Bro's video is conclusive? I didn't say it was conclusive. I just said that, in theory, that's exactly what I predict. I didn't say it was the perfect experiment and that we don't need to do any better ones. But I'm saying, go ahead, try. Try to improve on that experiment. Please do it. All right. Or does he want to make a retraction? Why would I retract anything? 1.7 clearly isn't 1.3. I mean, it's more than, 30% off. I suspect I know the answer, assuming Gary is even halfway honest. So, whatever. Again, I have nothing to concede here except victory. That's right. I will declare victory. Yes, I win, you lose. And that's going to become more and more apparent the more experiments that are done, and eventually we'll have ones that are more credible than Stephen Bro's 40% margin of error videos. But again, why don't you make a video just like this about when Stephen crashed objects into springs and got the result of 14 when my prediction was 12 and his prediction was 16. Why don't you make a video just like this, pointing out to Stephen how you've totally misrepresented the truth and you've distorted reality and blah, 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 blah. All this bullshit. Because in that case, it's an accurate statement. Stephen Bro put the video up because he's saying this proves kinetic energy when it clearly doesn't do that. All right. So again, I'll just say, go watch Brozo's experiment. And it'll be quite obvious to you that, yeah, that lighter object looks like it's going twice as fast. Because that's exactly what it looks like. Anyway, enough said. Alright, so that was interesting. Funny. That's what it was. Oh, look, they've commented already. 8 whole comments, too. Hilarious. Alright, let's see what Stephen, who says he already has done a better version of the video proving kinetic energy. So let's see what he says. He already has it. He already has the experiment. He already did it. He already proved it. We just have to wait to see it. Okay. The actual reason nobody commented on it was because I took it down almost immediately. What? Along with all my recent videos at the time, due to pressure I was under in my personal life, made worse by parapologic trolling with dozens of pointless comments. So, so making the arguments. Oh, nobody is allowed to do that. Which is why I finally blocked her. I gave her more chances than Gary ever gives anyone. Oh, isn't that just a nice little faggoty story there? A week or two later, I restored my videos because I got through the event that had caused me the great deal of worry and anxiety. But of course, that harms the video reach. So this is just crap, right? It was up for quite a while. And the fact that nobody commented is because, gee, it wasn't a very good illustration of your point. It wasn't very good evidence for your side. Yeah. Anyway, the angular, so again, this more angular crap. It's a tiny amount of angle. You can understand, right? On a 1 meter lever, it's a tiny amount of angular change in the velocity. Tiny. Okay, the angular momentum predicts that both balls, each their own run, have the same velocity. So it just can't even make any sense that they would have the same velocity. It's impossible for a lever to produce the same velocity. Impossible. At these different, the further out you go, the velocity has to increase. It has no choice. But launched in one run, the larger R has twice the speed. Well, isn't that speed the velocity, you retard? Independent of the mass of the balls. I mean, it's just too silly. Of course, it's not independent. It has to be a half mass. Oh, since the rod gives them the same... Oh, I'm not going to bother... I mean, too silly. I mean, this guy is so fucking nuts. I don't, So Godfrey, that's will be funny. Gary's goal is endless argument. No, my goal is to show you despicable, cowardly, lying sacks of shit, okay, to be what you are. Disgusting, lying sacks of shit. You're propagandists. You don't care about a fair argument or a fair fight. You are here to disrupt. You are not here to, and corrupt. You're not here to have justice be done. All right, not a successful argument. So again, we'll see. Oh, Piero! I thought he was dead. Oh, fuck. All right, Gary is picturing the lever. This ought to be hilarious. I mean, Piero can't understand any simple mechanical process. I'm amazed he can keep his shoes on the right feet. Gary is picturing the lever pushing the object ball. Yeah, that's exactly what it does. But really, the object ball flies off just like it hit directly. If hit directly. The whole point is you're pushing it. You don't want to hit it. Hitting is a different kinetic reaction. When you hit things, then they can bounce. They can reflect. Okay? When you push, you're more certain to get the energy into the object. It's really a huge distinction, right? So this is another example where Piero has no clue, right? Because I think you can understand the difference between pushing something, right? Making contact and then pushing and smacking. Two different things. All right. All right, but in the opposite direction. Anyway, the transfer of energy is almost instant. No, it takes time for the lever to move. It's moving a velocity. It has to, one object decreases its velocity while the other object increases its velocity. That's how the damn thing works, you retard. God damn, he's so stupid. It's just marvelously stupid. You just don't see stupid like this. You know, they ought to make the world according to Piero. You know. Anyway, and the lever may not move at all if the weights are matched. Clearly the weights are matched. That's the whole point. Okay? In the sense that you have to match the weight of the object, okay, for the experiment to work. So you're taking things with different masses and putting them in positions where they will have different weights. Right? So you can make one little bullet weigh 1,000 pounds if you put it far enough out on a lever. Fun fact, retard. Yeah. Just like a stop shot in pool. That's, I mean, clearly that's not what's taking place here. See, the lever, the Newton's cradle only works if the masses are the same. The whole point of the lever is that it allows you to do what a Newton's cradle does with uneven masses, because it proportionally adjusts the velocities. A slow deceleration can mean a fast acceleration. So now you can match the accelerations and decelerations, where in the Newton's cradle you can't do that with uneven masses. So I've said that so many times now. Right, is that 100 times I've said that point? Huge point, huge way of understanding. Why does the Newton's cradle fail to get the energy from light objects into heavy objects? And why does the lever succeed? All right. And it's for that simple reason, that it matches the uneven acceleration rates. It's an impulse, not an extended pushing up to speed. So again, that's just foolish nonsense. Okay, there's no hitting involved. There's no instant. The lever moves at a velocity. All right. So this is just hilarious. I never thought about it like that. Yeah, because it's stupid. Why would you? Oh, so now he's doubled down on being a retard. He's taking perception advice from Piero. Piero's the idiot who really didn't understand there was a difference between the single slit pattern and the double slit pattern. Piero's really stupid. Anyway, had to scratch my head a moment, but I think I get it now. So he just keeps doing this. Oh yeah, I get it now. Oh yeah, sure. I understand why. No, you don't. And you know you don't. MC was kind of arguing over the length of time the mass was being accelerated. Exactly. What do you think the fucking lever's doing? It's changing the velocities. It's taking a slow deceleration and turning it into a fast acceleration. Duh! I've said this 600 times. Oh, I'm just amazing. Suggesting they should somehow be accelerated over the same time period. They have to be accelerated over the same unit of time because it's a stick, you retard. It's a rigid stick. One side can't it has to all happen at the same time. It's in the same universe. These people are so stupid. I couldn't fathom why that should matter as long as the correct speeds are attained. Yes, exactly. Nor could I fathom what he meant about how I should be accomplishing this with a lever. I don't know who he's talking about. I have no clue what that could mean. Maybe I'm thick, but I couldn't follow his logic. Follow whose logic? Follow what logic? What are you talking about? I mean, they must have other comments somewhere, but you're just like sometimes saying, what are you talking about? Oh, MC's talking about. Okay. I don't know what he's talking about. MC's comment on the other video didn't say anything. Okay, that's why you didn't understand it, is because it didn't say anything. Alright, anyway. Piro. Thought experiment. Oh, amazing. Amazing. This ought to be brilliant. If you have an object ball and a cue ball on a lever, so he hasn't even seen Brozo's experiment where he actually has a cue ball on a lever. He actually has a billiard ball on a lever. Hilarious. He hasn't even watched this video. Okay. At equal length from the fulcrum. Well, why would I do that? But okay. It's just like a pool shot. Yes, it's just like a Newton's cradle. Same masses, same location, same result as a Newton's cradle. You just take the energy from one side, put directly into the other side. No problems. You don't have to do any conversion. Okay, the cue ball hits the lever. The energy is transferred through. Perfect, and the mass is massless lever. Now the point is you can't hit the lever. So you can't hit the lever into the cue ball because the lever will bounce off, okay, because it's not going to have the right mass. But the point is, he's saying put the cue ball against the lever. So he's trying, he's just confusing the simple argument. Okay, it stops and the object ball leaves at the same second. So this is a nothing thought experiment. In the context of these 2 years of videos, he just said absolutely nothing. All right, now with different size balls, that's right, at the right distances. All right, if the cue ball is bigger. So what is he talking about? If the cue ball is bigger, there's no bigger cue balls. When it normally hits the cue ball after the collision, the big ball will keep moving. So now he's talking about hitting physically a big, heavier mass into a lighter mass, and how the heavier mass has more momentum, pushes the lighter object at the same speed it's going, and it loses speed. So it's a bowling pin getting hit by the bowling ball argument. The bowling pin can only take the momentum you can give at that speed. It can't jump away from you at a higher speed. So obviously the faster your ball is going, the faster the pin will go. Alright, well, anyway. Now with a different size ball, I can't believe this is so stupid. If the ball hits the bigger ball, okay, so that's just talking about a big thing hitting a small thing. And then you have the opposite circumstance of a small thing hitting a big thing. And the problem is the small thing bounces off. Alright, anyway. And that proves relativity bullshit. But anyway, that's a whole nother argument I have made many, many times. If the half ball is on the lever, but twice as far, the advantage is that the energy should be transferred, but again, the lever doesn't even really move. It just transfers the energy in an instant. So this is just nonsense. Obviously, the lever has to move because it's going to cause acceleration in the ball. So that's just bullshit. Now, theoretically, let's say if you made it a lever out of steel, okay, something that transmitted energy almost perfectly. But again, the mass of the lever would have to be the same as the ball. I don't think you can get around that. Yes, you're still dependent on the movement of the lever. So that's not going to work. So instead of dealing with the real world experiments, right, he's trying to contrive some way that he can engineer this, into not the same experiment. All right, anyway, so Stephen Brooks says, yes, I can see now you've explained. Thanks. It's annoying how imperfect real levers are. Oh, amazing. They're so fucking reliable. So the most dependable device over thousands of years, and he's sitting there saying, it's annoying how imperfect real levers are. Amazing statement, considering that humanity was using them for thousands of years to measure their fortunes. Okay, it's harder for this to be immediately intuitive. No, it's really fucking easy. The lever theory is really easy. Twice the distance, twice the velocity. I mean, you almost can't get any simpler and easier. Oh, fuck. So anyway, that was all quite... I mean, these people are just so fucking obnoxious. They're just so fucking wrong. And they just keep trying to contrive defenses for an idea that they're going to break conservation of momentum. Let's just understand. You have to break conservation of momentum, the law, to disagree with me. If you're disagreeing with me about how the lever works, you have to do it. You don't have any choice. Okay, you're basically saying you don't believe in conservation of momentum. There's no way around it, because every time you transfer energy from a lighter object through either a hydraulic system or a lever or a spring into a heavier object, you have to lose tons and tons of kinetic energy. Yes, you'll perfectly conserve the momentum, but you have to lose kinetic energy. And every time you go the other way, you have to make free kinetic energy, because you have to conserve the momentum. Alright. So anyway, thank you for the link. I mean, thank you for letting me know. I didn't know about that video, so that was a bit entertaining, I have to say. I mean, the idiots who just haven't paid any attention, don't know any of the... Like the Godfrey guy doesn't know shit about anything physical. And then just for Piro to chime in again in his lazy, stupid manner, where he hasn't followed any of the conversation or any of the arguments. Amazing. Alright. So let's see what we got. Made a new video. Okay. Sorry, video. Yeah, that's what... Okay, I'll move that over here so you can almost see it. You can see enough of it. Fuck you people. You don't need to see it. I'll read it. I'll read it my way. Let's see. Sorry. Okay. That's this guy again. Conservation of smoking. Okay, so you're too dumb to be... for me to waste my time reading your comments, I guess. Well, you think... I'm not embarrassed that I'm a nicotine addict. I mean, I made the choice when I was 11 years old. Yeah, it was a stupid decision. Blah, 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 blah. Is there some other subject here, fuckhead? I don't think so. I don't, go prying into your life and ask why you, stick candles up your butt. I mean, you probably have lots of things you do that I would find obnoxious and disgusting. So just shove it up your ass, like the candlesticks and bowling pins and all the other fun things you shove up your ass. You fucking useless sack of shit. Ugh, god damn, I hate people. Alright. It's clear to me that mindless marbles is just trying to do some character assassination with his tactics. Well, I'm just saying, obviously he didn't deal with the real subject, that Brozo's experiment was not very good for the KE side. Okay, so that's all. And I'd say, sure, it's really great for my side because it wasn't great for the KE side, right? So it's got to be good news for me. I mean, you only have two choices. Either Brozo completely fucked the experiment, okay, or, okay, I was right. Alright, so sad that they have to resort to slimy tactics. Tactics, yes. Haven't seen Piro in a while. Yes, like I said, I did think he was dead. Some people never change. I thought he drowned in his little golden pond. The stupidity is just baffling. Honestly, I don't know what to add. Piro is a good example of the side you don't want to be on. Right, it's that he's ruined liberalism, right? He's one of these, huddled mass collector kind of philosophy. He doesn't have any notion of reality. He thinks we ought to tax property and that would solve all our problems. I mean, he's just an idiot. Okay. Yeah, anyway. Let's see. It's baffling how these people don't get it. 4 times more fuel to go twice as fast makes more sense as speed increases due to the resistance. So you can say that. Well, how does it make sense to you? Did you think it actually happens? In the real world, you think it actually happens. So you think that twice the speed of the turbine. So if I increase Niagara Falls, I make the water go twice as fast and I turn the water wheel twice as fast, that I get 4 times the energy out. Anyway, a car from 200 miles an hour to 230 requires more power. Well, of course it does. It requires more for you applying more pressure, but just like as the gravity argument shows, I can use, the same energy and I can go 4 times the distance. I mean, you're really just not following along. How your theory can't make any sense. It's not possible for it to make sense. But, well, whatever. Go ahead. I'm just saying you're not citing anything. So in the 350 years that morons like you have sat there and said, yeah, it seems like it's twice as much work to throw a half as light object twice as far. I could, what other good example would be? Pushing a kid. The 60-pound kid is 4 times harder to push than the 30-pound kid. 4 times harder to push. That makes sense to you. Let's see. I mean, I keep saying things like twice, and I don't mean to say twice. It's 4 times. 4 times the fuel to go 60 miles an hour than 30 miles an hour. Let's see, what other way is there to say that? So I'm just saying, in 350 years, your theory hasn't been shown to be true by any experiment ever conducted. So you have zero evidence of it. And certainly NASA proves it all the time, like I said. I mean, why do they shoot the rockets so fast into space? It's not because they're paying per mile, okay? It's because they're paying per time. The faster they get there, the less fuel they'll have to use. All right, let's see if we get anything else. Maybe a couple of minutes, and then we'll call it a video. It really is getting long now, right? Well, an hour and a half isn't terrible, but it is getting to be the hour of getting outside and doing some work. And I probably have to refill my nicotine. Yes. Yes, I do. Alright. What stumped me was the comment made about levers being questionable. Scales having been used for many. Yes, it's just amazing that Brozo said they're so unreliable. I mean, come on. It's true, they have just kept evading. I'm just saying that today was the first time. I mean, the Gostling guy basically admitted, oh yeah, there is a problem. So at least, he recognized I made my counter argument. He realized, okay, yeah, that doesn't add up. I have to explain why it doesn't add up. So I better get to that. Yeah, well, Pirro is just such a, he just shows up to make his little quips, and that's it. He's never dealt with any of these subjects seriously, because if he really had to deal with the facts presented, in a in a form where he wasn't allowed to just evade and evade with word salad, soup, garbage, he'd be done. I find it interesting that Pirro just comes out and of nowhere tried to blow and fart on the discussion. Exactly. Hasn't paid any attention to the detail of the arguments, nothing, and then gives us some baby talk about how levers work. Absolute baby talk in the context of all of the conversation that's taken place. He's just, it's a disgusting tactic, really, just to show up and troll. He did that on the whole double slit thing. He never dealt with the fact that the two patterns. He never dealt with having to answer any of the questions. And it's just, it sucks that people just keep evading the actual arguments. 5-minute video 2. I and Gostling made a new 5-minute video 2. Oh, there's another one. If you want to touch that video for next time. I don't really want to do either, frankly. I mean, it depends on what he's saying. He ought to just stop making videos for a minute and actually figure out what he thinks the answers are. Rather than do all this, saying this is ludicrous, that's, I already responded to this. Frankly, this video started with that video, okay? So you're a little behind. I already dealt with his new video. That was the whole point of this video, is to point out how, he's conceding a big chunk of the argument. But like I said, it's unfortunate that he did it so poorly, in the sense that he's, oh yes, it's 3-4, when now it's 2-4. If you don't make a mess out of the drawing. Alright, well, probably enough. So, I think I will get on with my day and such, and so forth and whatnot. And thank you to the participants. It says 3. 3 viewers. There's 17 in the other number, yeah. So 3 and 17. I can show you that, I think, yeah. Look at that. 3, 17. 3, 3, 17. 3, 17. Anyway, thank you, YouTube. It's very informative. I guess YouTube's more broken than a lever. Yes, next time and such and so forth and whatnot. So I'm out of here.